The last two examples of this section shows you that oftentimes you may have to combine different rules for a problem. So let's look at the first one. If you look at the function, you will see that you see a quotient, right? You see a quotient, and inside the quotient, in the numerator, you also see a product. So sometimes you have to combine two rules. So let's do the first one. So when we find the derivative of this function, so first of all, it's product, it's quotient. So we are going to use the quotient rule, low square on the bottom, low d high on the top, right? So I'm going to write this. Don't be too aggressive. You just want to do that step by step. Minus high d low. So high times the d low. Now let's implement all these rules. The low square, the low d high. Here it comes the products rule. So it's going to be equal to the derivative of the first function, which is 7 times the second function, plus the first function, which is 7x, times the derivative of the second function, which is e to the x, minus 7x e to the x, and the derivative of this is just 1. So now we could simplify by expanding the top. So the first, let's FOIL it out. So it's going to be 7x e to the x plus 7x squared e to the x plus 7 times e to the x and plus 7x e to the x. So that's after we FOILing out the product. That's what we have, minus 7x e to the x. So these two can be cancelled, and so we're left with, and then it seems like e to the x is a common factor, so we can factor out 7 and e to the x. And then let's rearrange the orders from the highest to the lowest. So x squared is the highest. The next one, x, is the next highest, and the 1 is the lowest, divided by x plus 1 squared. So after simplification, that's what we have. Let's practice one more. So in this case, the bottom is actually a product, right? Okay, so let's find the derivative of this function, which is low square and low d high on top. The derivative of high is just 2. So sometimes if it's not too bad, you can just simply do it immediately. So minus high d low, so 2x minus 1, times the derivative of the low, okay? So you're finding the derivative of the x, so you're finding the derivative of this guy. So let's use the products rule right now. So it's going to be derivative of the first one, which is 2x e to the x, plus the first function times the derivative of the second function, which is e to the x. Again, let's expand it. This is 2x squared e to the x. So first term is, keep in mind there's a negative sign in the front. So whenever you expand it, when you drop the parentheses, you have to change the sign. So the first one is 2x times 2x e to the x, which is 4x squared e to the x. Outer is 2x times x squared. By the way, that should change the sign. I should have minus sign. So 2x cubed e to the x. The inner term, it was -1 times the other one. So with this minus sign in the front, I have to switch the sign. 2x e to the x. And the very last one is plus x squared e to the x. over x x to the fourth e to the x squared, right? E to the x squared. So let's see what terms can we can cancel. So this and this is like term, and also this is like term. They are all x squared e to the x. So let's combine the coefficients. So this is 2, this is -4, we get -2, -2 plus 1 is -1. So we have -1x squared e to the x. And that's pretty much it, right? We cannot cancel any other terms. So x to the fourth e to the x squared. And let's factor out a common factor here. So we see that 2x e to the x, that's the common factor. And let's rearrange the powers from the highest to the lowest. So this is the highest power. After factoring out 2x e to the x, we are left with -x squared, right? 2 is not a common factor, I'm sorry, just -2x squared. And the next one is minus x. This is my next highest term. And the lowest term is just plus 1. X to the fourth e to the x squared. So we can cancel a 1e to the x. And we can cancel 1x. So eventually this is what we have. X cubed e to the x minus 2x squared minus x plus 1.